Okay, so 2000 higher paper question 23 on pressure and upthrust. So you've got a sonar detector that's immersed in a freshwater loch. With a cable you've got a certain distance to the top surface, a certain depth, and then another depth to the bottom surface. So the bottom surface is lower than the top surface, so there should be a pressure difference and therefore there should be an upthrust. So you're given some information there. The detector has a mass of 100 kilograms, atmospheric pressure is 101,000 pascals. Show that the total pressure on the top of the detector is 108,350. Sorry, that's given, and then show that the total pressure on the bottom of the detector is 111,290. Okay, so what you need to do is calculate out what the pressure on the bottom surface due to it being immersed in the fluid is. So that will be rho GH, just as we've talked about. You would go to the data sheet at this point in time and you would find out what the density of fresh water is. I gave you that was 1,000 kilograms per metre cubed. G, as always, is 9.8, and the depth to the bottom surface is 0.75 plus 0.3, so therefore it's 1.05. So the pressure due to the fluid alone is 10,290. So what a lot of people did there was they got that answer and then they thought, wait a minute, that's not the answer that we're looking for here. And a lot of you were able to figure out that you needed to add atmospheric pressure on, and you will have to do that in any types of situation like this, because there is air pressure as well as pressure from the liquid. So they're both fluids, whether it's air up here or whether it's the water down here, they're both going to have some sort of contribution towards the pressure acting on this object. It's the air pressure that's acting down on this surface here and keeping it flat, just like, you know, a glass of juice is flat, it's due to air pressure pushing down on it. So you've got to add that on. So your total is 10,290 plus 101,000 from your atmospheric pressure will give you the value that you need. It's 111,290 pascals. Remember, pascals are one of our units for pressure, the other one being newtons per metre squared. They're both equivalent. B, calculate the upthrust on the detector, and this is for 3 marks. So, you know, a lot of working to be done here, but you've got both the pressures that you need. You've got this pressure on the top there, you've got this pressure on the bottom. So all you have to do is to calculate the force on the top and the force on the bottom, and then figure out what the difference between those is, and that is what your upthrust is. So the force on the top will be the pressure on the top multiplied by the area of the surface. So the pressure on the top as given here is 108,350. The area is 0.4. So that gives you 43,340 newtons for your force on the top. Your area, remember, is given over here, 0.4 metres squared. It's the same for top and bottom surfaces. The force on the bottom is going to be the pressure on the bottom multiplied by the area. So the area is the same, but the pressure is larger. That's what you proved in the previous part. 111,290 multiplied by 0.4 should give you 44,516. So you can already see that there is a difference there. There's a difference in force. That difference in force is due to the difference in pressure. You get a difference in pressure because this bottom surface here is deeper in the fluid than this top surface, and because pressure increases with depth, then you've got a greater pressure here and therefore a greater force. So the difference in those two forces is the upthrust. So upthrust is the force on the bottom, which is bigger, minus the force on the top. You know, you're not looking for a negative answer here, you're looking for a positive answer, so take the larger number first. So 44,516 minus 43,340 gives you 1,176 newtons, which is the correct answer. So you're getting 3 marks for that. It's not really that complicated. These are standard three variable equations, like the ones you would have got in standard grade, and this is just a simple subtraction. So you're getting 1 mark for really each of these things. It's very straightforward, and all these questions on Upthrust follow that same technique. It's all about calculating the pressure on the top and the pressure on the bottom, using those to calculate force on top, force on bottom, subtracting the difference. It doesn't get any more complicated than that. The hardest part here is probably part C. The sonar detector is now attached, as before, to the bottom of a seawater lock. So that's your change. Everything else is the same. The top of the detector is again 0.75 metres below the surface of the water. The detector is also the same. There's no change here. It's that typical kind of last part of a question where one thing is changed and everything else is kept the same, and you're asked to kind of consider how that's going to affect things. Well, what you should be doing is looking for what the density of seawater is. So you should find that the density of seawater is, what, 1.02 times 10 to the 3 kilograms per metre cubed, so it's slightly more than the density of fresh water. You know already that pressure increases with density. So if pressure increases with density and everything else is the same, then the pressure difference must end up being greater, because we're going to have more pressure here. Pressure is going to be greater at the bottom here, it's going to be greater at the top. So we've got bigger numbers, we're dealing with bigger numbers, so therefore we're going to have a greater pressure difference. If we've got a greater pressure difference, then that's going to affect our force here. You could work this through, again, you could just pop the values in if you needed to. You're going to have a greater force here, so you're going to have a greater upthrust. So what you're looking to say is something along the lines of density has increased, so pressure difference is greater. I'm not going to write this out, but you know, in words you would put this. So therefore force difference is greater, so upthrust is greater. You could take this value, plug it in, keep everything else the same, and calculate it out numerically if you're not able to map things out this way. Remember, those are the two ways that you kind of tackle these types of questions. You can either look at the values from start to finish and figure out how putting a different number in would change things, or you can actually put the number in and work the calculation through. So greater density means greater pressure difference. If there's a greater pressure difference, then that means you've got a greater force difference, therefore a greater upthrust. So it's going to experience more upthrust, which is probably what you were trying to say anyway, because you know that the seawater is more dense, so it provides more pressure. But you've got to be able to explain that. So you're usually looking for 4 points in these to get these 2 marks. You get half a mark for making each of these points.